And we are back. So we've got a bunch of new files uploaded here that have all sorts of fun and interesting bugs into them. Um, anyone particularly proud of yours, we can use yours as our demo for a GDB, because that is the topic of our lecture today. How to use the GNU debugger. The GNU debugger, of course, is GDB, written by my boy Richard Stallman. So you liked yours? Okay. So Vim Brandis. Oh, it's with a capital D. All right. We'll just cd into my home directory, and I will copy /temp/noon/Brandis to my home directory, or to dot, either way, because I'm in my home directory right now. And I'm going to lowercase u just because I want to. All right. So the goal of this program. is to output a rectangle with the user's chosen dimensions and made out of the user's chosen character. For example, width 3, height 3, character Q will do that. Cool. There are 4 bugs. All right. Use namespace stood. All right. So first of all, you have to remember that GDB doesn't help with compiler errors. GDB is a debugger. Debugger means that you run the debugger, then you run the program inside the debugger. That you do things like step your program one step at a time and look at it. So we first have to get this thing into shape using namespace std, because we like getting rid of stds instead of having stds. This is all compiling. Square is missing a scout. Maybe square doesn't return anything, so okay. We'll just pop off the end there, and we should have a compiling thingy. Let me scan it real fast to make sure that there's no like rm-rf commands in here that'll erase my erase all my files. Looks fine. When I auto grade your homework, by the way, I compile it and run it as you. So if you were to ever submit a homework that like deletes all the files on the system, it'll delete all of your files. Won't touch anything else. So okay. So in order to do debugging, you have to compile your code with the -G option here. I'm turning off the alias with the \. I think I have it. Yeah, I have debugging on by default, but I also have the optimizer on. The optimizer will actually screw up debugging. So I'm going to just do that with Brandis here. And that's how you compile the code with debugging turned on. So -G means debugging. All right. So now we got a program, enter the width, 3, bad input. Uh-oh, that's not good. So our standard approach here up till now is just to see out all the things. See out the width, see out the height, and try and figure out what's going on. But today, we're going to be learning the GNU debugger. So we're going to type GDB -out -2e. 2e creates this nice little text user interface. Without it, then you just get this, which doesn't look nearly as nice. It's a little more off-putting to students. So in 2e mode, I can scroll up and down and I can look at the code and stuff like that. And I can do things like set a breakpoint, which means it will stop on that line. So maybe I will set a breakpoint on line 41, because there doesn't seem to be anything up till then. Yeah, okay. So I'm going to set a breakpoint. And so B is the command to set a breakpoint, or you can say break on line 41. And so you'll see on the screen here that it now has a breakpoint set. And so that means when I run the program, it's going to run all the way until that line and stop. So I'm going to type run now. That's the second thing you need to know for the quiz today. Breakpoint's one of them. How to run it is one of them also. So this is the third thing for today. Run. Runs the program inside of the debugger. And it is now on line 39. It's inputting the width. I will type in 10. Now we're here. We've stopped. It hasn't done the if not cn yet. So we've got width, we got height, we got word. So I can print the value. This is bullet point number 4 you need to know. I can print the width like this. And the value of width is 10, which is what I typed in. So cool. All right. Let's print the value of height. The value of height is 0. It doesn't have to be. It's uninitialized. In the previous class, these uninitialized values had different weird values, and let's print a word, why not? And this one's also 0, but again, it doesn't have to be. These are uninitialized variables. On line 35 and 36, I would definitely want to initialize these values. So, if not cn, let's just step over this line. So when you want to advance to the next line, you got two options. You can step in or you can step over. Step in means that it's going to go into a function call. Okay? And if we step in like this, oh, it actually goes all the way to the next line. Okay, so it didn't treat that as a function call. Interesting. Okay. But things like the double left arrow are actually function calls. And so when you step into them, all of a sudden you're like in standard library code and you're like, oh my gosh, what's happening here? Ooh, I see. I think I might have found one of the bugs. So I'm going to step again. And now I'm inside the if statement that's about to print bad input. Now I'm going to step into this. Normally I would type instead next. Next goes over the function instead of into it, because I do not care about the operator double left arrow function to print things to the screen. But I'm just going to show you what it looks like. Did it skip that too? Step? Did it not print anything? Interesting. And step. Interesting. And finish. Yeah. Okay. So if we run this with a width of 10, it prints out bad input and quits. Okay. So you can see here, that's the problem, right? We got to the, you can just trace the execution of the program. You can see, oh, that's why we got bad input. It's because width is supposed to be less than 1 for it to be bad input, not greater than 1. Okay, so we fixed it. We're going to recompile our code, again with G++-G, like that. Rerun the debugger. Actually, we can just run the program and see if it works now. 3 and 3, please enter your character, Q. Aha, infinite loop. Okay, so it's not working quite yet. So we're going to run the debugger again. And now that we're happy with that code, height and width, all that seems fine. It seemed to get past all that fine. So our real issue is actually within the square function. So I'm going to see what line of code I'm going to break on here. So let's go and break on line 18 and hit run. Okay, so what is our width? 3. What's our height? 3. Enter your character, Q. And then we get to line 18 and it stops. Yep. Maybe you should have made it harder. No, this is good. This is exactly what I was looking for. You did a great job. Okay, so okay. So if we wanted to, we could print the value of I by typing print I. It's uninitialized yet because it stops before the line, not after it's run. So after we run this line, if we go to the next, you'll see if we print print I, it's now 1. And if we go to the next, we can now print the value of J. Okay, 1. Okay, so if height is equal to 1, if I equals 1 or I equals height, or j equals 1 or j equals height, then we print out word, which is the character, followed by a tab with a okay. Now, if you have weird printing errors on the screen, because when you're c-outing things, it'll appear on the screen, Control L. Control L will refresh the screen. Okay, so there wasn't a th there. Okay, it was just like c-outing directly to the screen. Okay. So if I is 1 or height is 1 or j is 1 or width, or j equals width, then we are going to output Q. Okay, so we're going to go next, and somewhere on the screen, I'm sure it just printed the letter. I don't see it. It's one of the reasons why 2E mode is kind of annoying, is that, like, it hides the actual output sometimes. Okay, and then we go next. And oh, haha. Yeah, it should have printed this. Yeah, I is still 1. Okay. All right. So we're on I equals 1, and then you can see it is now in an infinite loop. It should have only gone 3 times, right? So the reason why this code is looping infinitely is because that is an I there on line 19. It should have been J. So it should have been J equals 1, J is less than or equal to width, J++. Okay. And so do you guys see that though? By using a debugger, you can just sit there and step through it. Be like, okay, it's doing this, it's doing this, it's doing this. Wait a second, it should have stopped by now. It should have stopped by now. Why is it still doing this? You know, and you can actually watch your program run, and you can examine the values of any of the variables whenever you want. You can do something called backtrace. Backtrace will tell you which functions you've come from. So if this function, if function A calls function B, calls function C, you type backtrace, which you can either do by typing it out, which nobody does, or you just type BT, which everyone does. And then it'll say you're in function C, which was called by function B, which was called by function A, which was called by main. And you can actually look at the call stack, and you can see all the parameters there. So you can see that square was called with width 3, height 3, with Q as the character passed in. On line 19, it was called from main on line 71. So you can see everywhere you are inside of the code. We were here on main, and then we jumped up to line 19 here, and that's what's going on right now. So if you want to finish a function, which means like if you accidentally step into a function and you want to step out of it, you type finish. This one, however, won't finish because it's an infinite loop. So let me fix it first, and then let me fix this. This should be a J like that. Compile, run 3.3Q. All right, cool. Code's working now. Let me just run the thing for you. So let's set a breakpoint on line 20. Hit run. It runs up to that point. 3.3Q. And again, when it's printing things, the formatting gets all screwed up. So Control L, refresh, and I can go next and next and next and next and next and next. And there we go. Okay. So that's the first line. Okay. And now that I'm confident that it's working right, I can just be like, all right, just get me out of here. All right, just get me out of here. So as you finish, and oh, it's going to set the breakpoint again. So we can clear the breakpoint on line 20, and then finish. And then we are now back on line 72 of main, right here. So finish means keep running until you exit the function. So step will step into a function, next steps over a function, and finish steps you out of a function. Maybe let me give you, let me maybe make that a little bit more, no, not you. Let me make this maybe a little bit more clear by maybe adding one more Coutts in there or something. Okay. So let's say that I set a breakpoint on line 71. I hit run, and so we've entered the width, the height, the character's Q, and now we're about to go into this function here. So sometimes I want to go into the function and actually see every step as it's going, and that function is called step, and now I'm inside of square, and I can hit, next over and over again, and everything's fine. If I were to step here, it looks like it's not taking us into the standard library. It does sometimes. Okay, finish to get out. And then we can go next. And then next, and we're done. Okay. So that was step. So step will breakpoint on 71, run. So step is going to go into the function. But sometimes you're like, I know this function works. Let's just go over it, right? So I can hit next instead. So if I type next, then it just prints the square like it does the whole function. And now we're on the next line, right? So step goes into that function, next goes over it. And so between step and next and finish, you can kind of control going down into a function, coming back out of a function, stepping over a line. Sometimes, like I said, you'll sometimes find yourself trapped in the standard library somewhere. Let's see if I can show you an example of that, because it's scary. It's like you're lost in the woods with no how, I don't know, width and height. Let's see if I can step into this. Just missed something. How do you put your file to the temp directory? CP. You need CP to do so. Breakpoint on line 72. Run. Okay, so we are on line 72, and I'm going to step over it because I'm confident now this function works. I'm going to step over it by saying next. Okay, prints out the whole thing. And now we've got POW here. So let's see if I can enter it by doing step. Yes. Okay, here we are in standard library world. So it's just like, wait, what just happened here? Right? So a lot of times students will be going step, 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 and it's just like a school child stepping along a path, happy, yay, everything's fine. And then all of a sudden you see something that looks like this. You're just like, what happened? None of this makes any sense. There's a lot of underscores and stuff, and promote to, and all this kind of stuff. And it looks really terrifying. And you want to get out of there, right? So I would just do a finish, and then it comes back out. All right. So if you ever step too far, you've delved too deep. The dwarves were too greedy, and they mined too deep. If you go too deep into the standard library, you can type finish, bring yourself back up to your code, and you can see that it returned the value of 27. 3 to the third power is in fact 27. And we can go to the next line. It printed out 27. Go to the next line. It printed out we're done. And then that's it. Yep. So that's a debugger. All of you guys have inside of your directories now a folder called GDB. And GDB has a file called GDB Notes. And this has all sorts of information for you guys that will be very helpful for doing GDB. So for example, you can put set2e border kind space to make those nice little borders that I have there into what's called a GDB init file. Compile your code with -G to make the debugger work. G is for debug. You can run it in 2e mode. That's the one that has that nice text window up top. Set a breakpoint, show your breakpoints, delete a breakpoint, run your code, print a value, watch a variable so that if it changes, it breaks. Step into, step over, step out, continue after you hit a breakpoint. We'll continue running, backtrace up. We'll take you up a function level so you can look at where you were without actually doing a finish. And that, my friends, is the fast introduction to GDB. So those are all the most important things. You can run it without being in 2e mode. Where was that? Okay. GDB 8.out. I actually, am quite comfortable with just using command line mode. Break line 72, run, and okay, here's the line you're on. This one, do you want to go in or go out? Let's go into it. Here's the line you're on. Okay, next. Okay, print the value of I1. Okay, next. And it prints each line as it's running. And I'm actually really comfortable with this. Like, it just shows you this line of code just ran. Okay, well, let's print the value of width and make sure that it's what we all... Okay, it is 3. Great. Okay, go on to the next one. All right, print the value of J. All right, cool. Everything looks right. Finish. You understand? So I actually am quite happy with the command line version of it. But for students, and 2e is nice. I do use 2e a lot, too. You can switch back and forth between 2e mode and command line mode. Control X, Control A will switch between 2e mode and command line mode. Because sometimes I want to refer back to my source code, and mouse wheel support and all that kind of stuff is pretty neat. You just mouse wheel up and be like, break line 27, and okay, cool. And then I do that, and then I say break on line 27, and so that is a thing you can do. Control X, Control A switches back and forth. Control X, Control O switches the window that is highlighted. Control X, Control 2 shows you the assembly. Control X, Control 2. And now we've got 3 windows open. So you can have the source code, the assembly, and your commands all running at the same time if you're into that kind of stuff. And finally, Q is quit. And if you're running it currently, it'll be like, are you sure? And you're like, yes. And that's GDB. Thanks for coming out, everyone. I'm going to go through your submissions for debugging tonight. Give you extra credit if I liked it. And we might do another debug fest with some of the student-made debugging problems. I might give some of these to the the 26 students tomorrow, my third semester students, and see if they can solve kind of, you know, some of your problems. See if they like it. Maybe actually next week. I think I might have to teach Unix shell scripting tomorrow, but that is it for today. So thank you for coming out. Hope you guys all had fun making bad code for once, not just doing it accidentally, but actually using your C/40 powers for justice to make deliberately bad code. So can you update your file before tomorrow? Yeah, I'm probably going to look at it tonight. I've got judo, and I'll be back at like, I don't know, later. I'll probably look at, like, honestly, knowing me, it'll probably be like midnight when I start grading them. So feel free to update your bugs. Make you know, as tricky or obvious as you want. Have fun with them. If I like it, you get extra credit. You don't think yours is wrong enough? Channel your skills. I know you can write bugs. I know somebody in the C/40 class, like, I don't know how to write a bug. And I'm like, you've been doing it all semester. I believe in you. Whatever it is you did wrong last week on the assignment, do that. You know, like whatever bug you typed by accident, just put those in. You know, and we'll have fun. We'll have fun finding them. So it's it's like a Uno reverse day here in C/40. So use yeah, all the mistakes you've made, you know, for the powers of good, and have fun with it. Okay. Do you have to recopy it if you update it? Yes. Yeah. So if you've updated the file, then copy it back up and make sure you chmod it again. And that's it. Thanks, guys. See you on Friday.